Seems like it should be. All right, we're gonna continue our look at exponents, guys. All right, now we're going to look at what happens with numbers. We've been working a lot with bases that were variables, letters, right? And all of the different things that can happen. Well, today what we're going to do is we're going to work on what happens when the bases are numbers. Because remember that when we were working with exponents, we can multiply, we can divide, but the key there is that they have to have like bases in order for that to work. Right? So like a to the third times a to the second is a to the fifth, right? A to the fourth divided by a to the second is a to the 4 minus 2, which is a to the second. But b to the fourth divided by a to the second is b to the fourth a to the second, right? You can't do anything with it because the bases aren't the same. Well, when you have numbers and the bases aren't the same, sometimes you can fix it, okay? So, when the base is a number, you can sometimes, not always, but sometimes change the number to exponential notation to get the same base. And again, we want the same base so that we can use those shortcut rules, right? So for example, if we have a 2 and we have an 8, guys, if we have a 2 and we have an 8, are they the same base? No, but 2 can't change. But can I write 8 as 2 to some power? Yes, you can. 2 to what? 2 to the third power. Now they're the same base, so we can use those rules. Okay? Now that doesn't look very impressive because you could just do 2 times 8, right? But when you're doing these, when they're you'll have some where you have some letters, some variables in your as exponents, etc., where this is going to look much more impressive. But I wanted to show you a very small example, okay? So the key is to look at the smaller number. It's usually a case of turning the bigger one into the smaller one to some power. Now, is that always going to be possible? Certainly not. If we had 2 and 9... I can indeed turn 9 into some power, but it's 3 to the second. Does that do me any good? No. Okay? So it's not always going to help you. But in general, it'll make your life easier to change those bases. And you must do it in order to be able to simplify them using those rules. And again, we'll see why. When we look at some of the examples, we'll see why this is important to do, to get these to be simplified. Okay? And that's really all there is to working with that type of problem. So powers as bases. So let's see. That's powers where the base is a number is on page 16. So we're just going to look at a few of these and see how to simplify them. Let's just start off small. Look at number 1, for example. Again, this is on page 16. We have 2 to the 3n over 8. Now that's not a 2. It's a 2 to the 3n. I could just divide the 2 and the 8 and make them simpler, but it would still leave me with the stuff in the bottom. I want to turn this into one non-fraction term with just an exponent. So my smallest base is a 2. Can I do the 8 as a 2, a power of 2? You bet you can. So it's going to come 2 to the 3n over 2 to the what power? 3. Now do I have the same base? Yes. Then I can use the division rule, which says that if they have the same base, we keep the base and do what to the exponents? Subtract them. So 2 to the 3n minus 3. Okay. It's 3n and 3, so they're not like terms, are they? Okay. Now. Okay, let me talk about this. So this one can be simplified slightly by factoring out the 3, and then you can do 2 to the third, making it 8. Her question was, what if the 8 already had an exponent? Well, we can still turn the 8 into 2 to the third power, but then that's raised to the third power, which makes it 2 to the what? 9. So you can still follow that same multiplication rule. Just remember that if you simplify anything to a power, if you do anything to it, it's got to mean that whole thing raised to the power, so it's going to have to be in a bracket. I said bracket before I said parentheses and corrected myself. I'm so proud. I'm turning into a New Zealander. Can you tell the accent already? No?
Yeah, it's coming through.
It's coming through? Okay, good. All right. So, look at number 3, for example. Okay. We have 64n, and this is really why these are important. It's when you have variables as exponents, because they don't behave like numbers, right? Okay. But they really do. Over 2 to the 5n. So do I have the same base? No. But I have n's as my exponent, so that's a good thing, because in a minute I can. So I know I can simplify this, right? But 64, can I write 64 as some power of 2? Yes. 2 to the what? 2 to the 6 power, right? All right. Now, but there was already an exponent up there. So you could so you'd bracket it, right? And then multiply them together, so that gives you 2 to the 6n. So in other words, if you recognize that's what's going to happen, you don't have to write out that step, but I want to show you in the notes so you know exactly what's happening. So that last one was a great segue into that. So anytime you take you change something into an exponent and it already has an exponent, you have to end up multiplying those two exponents together. Yes? 2 times 2 is 4. That's how I do it. I count on my fingers. But, some of you, how did you know that? You just knew 64 was 2 to the 6. Some of you just know it, but it's all right. But if you don't know it, don't worry about it. 2 times 2 is 4, times another 2 is 8, times another 2 is 16, times another 2 is 32, times another 2 is 64. That's how I do it. I've got fingers. And, right? Whatever yeah, and you could certainly do that. Trial and error on your calculator if you want. Okay? Now, in the bottom, it's already 2 to some power, so I don't care, right? Yeah. Now, do I have the same base? Yes, that means I can simplify it. And since it's division, simplifying it means do what to the exponents? Subtract them, yeah. So that gives me just 2 to the n. Nice? Yeah, that looks a lot better. 2 to the n looks a lot better than what we started with. Okay?
If you have something like 3 to the 3 and then 3 to the 2, do you just leave it as that?
Yeah, if you can't simplify it using the rules, then you just don't simplify it. Look at number 5. We'll just go ahead. We'll just do the odd numbered ones. How's that? 3 times 4 to the 5n. Because this book, typical of most math books, gives you things that are similar. If you do the odd, then the even is quite similar. All right. 3 times 4 to the 5n over 2 to the n. Now, when we're working with these, if these were the same base, we could multiply them and do the exponents, right? But what we need to do is turn that worry about these bases to be able to simplify and finish the division, right? Okay. So there's really nothing you can do to the 3 times business. But because it's multiplication, remember multiplication is that easy operation that'll let you do anything to it and it doesn't care. So I can still simplify this part even though I'm not able to do the 3 multiplied by 3 part. Okay? So 4 can be written as a power of 2. It's 2 to the what? Second. But I already have an exponent up there of 5n, right? So it becomes 3 times, so that's 2 to the 10n, and it's division, so minus an n, gives you 2 to the 9n. Nope. You happy?
Yeah.
Unhappy? So we can simplify the powers on like bases, but we can't do anything with the 3. And don't you dare multiply that 3 times that 2. Because it's not a 2, is it? It's a base of 2, which means you can't do any multiplication or anything with it, right? Now, had it been a letter, can I multiply that 3 times that? Not really. But I can stick them side by side. It looks like I've multiplied them. And so that's what your brain is thinking right now. Why can't I just stick those things together? But be careful. The reason you can is because you're not really multiplying those. You're just taking out the multiplication symbol. Right? So be careful. Okay? All right. What else? Look at number 7. 3 times 2n minus 1 over 9n. Okay? Now, can I change to like bases?
Yeah.
Sure. So I get 3 to the 2n minus 1 is not going to change. But 9n is going to become 3 squared to the n power, which is 3 to the 2n. Okay? Because 3 squared, you have the n power out there. We already had the n power. So now I have the same base. So that's 3 to the 2n minus 1 minus 2n. Right? You just use the division algorithm. And 2n minus 2n makes nothing, so that gives you 3 to the minus 1. Am I done?
No.
Not quite. 3 to the minus 1 becomes
1 over 3.
1 over 3. Okay? So it looks horrible, but in reality, it's quite simple. Right? These are pretty impressive. These would impress your friends if they were impressed by this kind of stuff. Okay? All right. So what we're going to do then is, finally, we're going to end our look at exponents by putting it all together. Now, I'm not going to do examples of each one of these, but we'll do a few of them. So what we'll do is we're going to do the even ones, so that leaves the odd ones for y'all. Doesn't really matter because you got the answers to all of them in the book. Yes.
Was there keys? I was question 8 on page.
So, all right, putting it all together. So now what they're going to do is they're just going to throw everything at you that they can. All right? Can we just not? No. Now, the thing to remember is that, guys, there is no real order of operations to deal with here that tells you back, like when you were doing arithmetic, how nice it was, that you always multiply, divide, etc. But do think about it, though, that brackets should always be done first, right? Always think about brackets first. You need to get rid of them, otherwise you can't continue, right? That is straight order of operations. If you have a fraction, then the first thing you do is simplify the numerator. And the second thing you do is simplify in the denominator. And then you treat it like division. So if there's anything you can do in the top, do it all. If there's anything you can do in the bottom, do it all. And then think of it as division. Okay? So there are a couple of places where we can think about things. Also, negative exponents. Watch out for those. Those need to be done when you come to them because you need to get rid of, you need to turn things over before you take the roots, right? So you cannot work with negative exponents. You've got to get rid of them before you can work with them. Okay? So there are some things that we can kind of prioritize. But other than that, it's just a matter of following the rules. Okay? So let's look at some examples. And if you see some patterns, we'll talk about them because I would love to have some patterns. Okay? This is fairly straightforward. We have a bracket, right, in the top of a fraction, so we got to deal with that first. 2x to the third I can't do anything to, but is there an exponent on the bracket? Yes. So that means that we can raise everything inside to the fourth power. So 2 to the fourth power, x to the 3 times 4 gives us, what, 16x to the 12th?
Yes.
Not too bad. In the bottom, be careful though, because there's not a 16 down there, right? That's the square root of 16. What's the square root of 16? 4. What's the square root of x squared? Plain old x. Remember the index, if you don't see one, is a 2. And when you have exponents, you take this one divided by that one. So that gives you x to the first, which of course is just plain old x. Now all I need to do is perform the division. 16 divided by 4 is 4. X to the 12 divided by x to the first is x to the 11.
Amazing.
Looks really bad to start with, but again, you're just going to peel away the layers using the rules. Feels good? All right. Okay, let's move on to some more. Look at number 6. We're not going to have a chance to do them all, but we'll do a good sample. Now, we've got something. We've got a bracket, guys. Come on, we've got a bracket, right? So we can take care of the ends. Is there something I can do inside that bracket before I do anything else? Yes. And even though there's a negative exponent on the outside, you should really start with simplifying inside the bracket. It'll make your life easier. So the 27 can't change, right? So it's going to just stay 27 in the bottom. But x to the 15 divided by x to the 9 is x to the 15 minus 9, which is x to the what? 6th. And why is it in the top? Because it was the bigger one is on the top, right? It's positive, so it didn't need to move, right? Now we still have to raise all of that to the negative 1/3 power. Well, negative 1/3 power, negative tells me that they're in the wrong spots now, right? I simplified them first, but now to get rid of the negative, I need to do what? Flip it. So it's 27 over x to the 6th, now raised to the positive 1/3. And raising something to the 1/3 power is the same as taking a root of it. What root? The third root of 27 and x to the 6th. Now, I'm going to show you this written out, and you don't have to do this, but I swear to you later in life that could make your life easier. That's the same as saying the cube root of 27 over the cube root of x to the 6th. The only reason I do that is because sometimes you can take the cube root of part of it and not the other part. And if you just try it as one big fraction, then you take the cube root of one part of it, you're going to think, cube root's gone, right? And that's not necessarily true. So anytime you see a cube root of a fraction, my advice to you is write it as 2 roots. Root of the top, root of the bottom. Because sometimes you can simplify one and not the other. What is the cube root of 27? 3. What is cube root of x to the 6? Oh, not if I do it. X to the 2nd. Because it's 6 divided by 3. Remember when you're taking the root of an exponent, you just divide the exponent. And there you are. So not too bad. Yeah? Are we happy that we spent so much time working on the small parts? Okay? All right. Yeah. Be free. Here's your workbook. Do these. Guys, okay, come on. Focus. My favorite is when the teacher just does a bunch of examples without any explanation and says, "Everybody see that?" I love that. That's my favorite style of teaching. Oh, that makes you so happy. There. Okay, here we go. We have brackets.
Is this question 10?
Yes. I'm just going to every other even one. So we have brackets.
There's a 4 after the x and the next one. After 25.
Oh, sorry. Thank you. There needs to be. It makes it a lot easier. Good. All right, now. I could multiply those two brackets together, but I would be breaking the rules. Why?
Negative exponent.
Because there's an exponent on there too, right? So I first look inside. 5x to the third, there's nothing I can do there. Is there an exponent? No, I'm not on that one. Is there a coefficient? No. But I can't get rid of the parentheses because this one is literally the coefficient or multiplier of the second one. And I need to keep that multiplication. Now, you could change it to put a multiplication symbol there, but I wouldn't. I would use the multiplication symbol of the bracket. Sorry, I keep slipping back and forth. That was so good. Had my New Zealand accent going on for a little while. Now it's gone. Oh, well. All right. So go to the next one. 25x to the fourth. Can I do anything inside? No. Is there an exponent on the bracket?
Yeah.
Yes. And that exponent is a negative, which means the first thing I need to do is get rid of that negative part. I'm going to take it off to the side and work on it and then bring the answer back over here before I multiply it. So that's just going to become 1 over 25x to the fourth raised to the now positive 1/2, right? Yay. And raising something to the positive 1/2 is the same as simply taking the square root. And since it's a fraction, I'm going to take the square root of the top and the square root of the bottom. They're being really nice to you and letting all of these work. If you want to put that little index of 2 in there, be my guest.
Wait, are there going to be some that don't work?
It's possible. I don't know. I haven't done this. 1 square, the square root of 1 is? 1. Square root of 25 is?
5.
Square root of x to the fourth is? X to the second, right? Because when you have an exponent, you take the exponent and divide it by the index. And now, what's left to do?
5x
Just 5x to the third. And we can put that over 1 to make it... Are you making fun of me? All right. I can't speak New Zealand. I can't speak New Zealand, but she's learning to speak Texan. Your parents are going to be so proud. I'm going to be fired.
Like you're not dumb me. I say y'all.
I used to say y'all just because that's what it sounds cool, but now I just say it all the time.
Yeah, no. I was like, oh no, I just naturally say it all the time.
Okay, come on, guys. So you can simply multiply straight across and then simplify it, or you could simplify it here. What would y'all normally do, you think? Do you think you would simplify it when it was still fractions, or would you multiply straight across and then simplify the end? Okay, that's fine. 5 divided by 5 is 1. X to the third divided by x to the second is x. So do I need the 1? Nope. Completed answer is x.
It's just x.
No.
It's like the funniest. You go through this whole thing, and all of this is just x. Like you go through this whole thing to see x.
Get used. This is what life is like, kids.
It seems so complicated eventually. You go through all the complications.
You do all this, and in the end, you're still old. Yeah. Okay. All right, let's do number what? What are we on? 14?
We should do number 18.
We're going to do 14 and 18. What time we got? How much time we
We
have?
have about 7 and a bit minutes.
We have time. All right, look at number 14. 4x to the second over x to the fourth, y to the sixth, all raised to the negative 1/2. Oh, this one's easy. This one's way easy. First of all, we need to get rid of that negative exponent by flipping them over. Yeah, we hope for one like this. Which means simply take the square root of the top and the square root of the bottom. Square root of x to the 4th is x to the 2nd. Square root of y to the 6 is y to the 3rd. Remember, because you just divide the exponent by the index. Square root of 4 is 2. Square root of x to the 6 is x to the 3rd. Am I done? Not quite. Why not? Yes, it would have been better if we'd done the x's here. Sorry, guys, I missed it.
Wait, where did we get x to the 3rd from?
X, the square root of x to the 6th.
But why is it x to the 6th?
Oh, it was x to the 2nd. Oh, never mind.
Don't put Mr. Self in a project.
He doesn't deal with it well. Crazy. All right, so x to the 2nd, so 2x. Now, x to the 2nd and x, one of the x's will divide away. Gives you xy to the 3rd over 2. Now, if you'd have done this, x to the 4th and x squared, that would have given you x squared y to the 6th over 4.
Which would be like the same thing.
And then you take the square root of both of those. Don't be lost. Let me go back. Let's just ignore it. Pretend I didn't do it. Let's go back. 4 x to the 2nd divided by x to the 4th, y to the 6th, all raised to the negative 1/2 power. And what is it that I said to always do that I did not do? Inside. 4 has nothing, but the x's will divide, right? X squared divided by x to the 4th. X 2 minus 4, which is x to the negative 2, which means it should be where? So that means that it's going to be x. So 4 over x squared y to the 6th. Do we see it? Still raised to the negative 1/2 power, which means then I need to flip it. So all I did was I divided these x's first. And that makes it smaller, which makes it easier, right? I should always do that because many, many, many times things will divide away, and that's better. So make sure you do the inside first. Right? It's x to the 2nd minus 4, which is x to the negative 2, which means that x should be at the bottom, right? Well, I was just doing the x part first.
Oh, okay, sorry.
It's still there. I haven't done anything to anything else. Now we'll just take the square root of both the top and the square root of the bottom. And we got there faster. Okay? But we still got there. We would still gotten there the other way too, but it just, right? We're working with bigger numbers. Okay? You guys are cracking me up. Okay. Let's give number 18 a shot. It's back, but hurry. Come on, guys. Let's get this last one done. It's back up. Are you done? You got it? Okay. Okay, number 18. The square root of 4 times 36y to the 6 over x to the 8 raised to the negative 1 power.
Oh, that's fine.
Do everything inside the brackets first.
There's nothing to do.
You swap it over.
There's nothing to do inside because you can't divide anything this time, but what does that negative 1 mean to do?
Flippy, flippy.
Okay. Flippy, flippy. And it's to the first power, so who cares, right? Now, we have some multiplication to do inside. So that's just 4 over 1 times x to the 8 over 36y to the second. Because 4 is just 4 over 1, right? I just like to make things, if I'm multiplying times a fraction, I like to make everything look like a fraction. But you don't have to.
That is helpful because I do not trust myself.
And 4 and 36 will both divide by something, won't they?
Yes.
Both divide by what? 4, yeah? 4 divided by itself makes a 1. 36 divided by 4 turns into a... Come on, kids.
9. So number from like 5 to 10.
It's not even Friday or anything. Come on. All right, now just multiply straight across. 1 times x to the 8 is x to the 8. 1 times 9y to the 6 is 9y to the 6th. And we still have to take the square root of that junk. Stuff. Wonderful stuff.
Wait, no, because then if we had left... Oh, wait. Hold on. It's just gone. What? Honey, nothing is wrong. It's fine. Don't worry.
Okay. Which means take the square root of the top and the square root of the bottom. You got to tell me where. I can't fix it if I don't know where you're...
Oh, no, it's okay. And then it's...
It's the fractions. What is it with fractions, you guys? What is that, like 5th grade?
And then I was like, then you can't.
Ah, I see. I get it.
There's an 8.
Square root of x to the 8 is x to the
4.
4. Square root of 9 is 3. Square root of y to the 6 is y to the 3. And can we simplify it any further? No. And I checked in the back and we got the right answer. I'm so proud. This is the kind of thing you're going to see on the test.
What?
They're not difficult, but you have to peel away the layers. Okay?
Surely just
All right.
we all huddle together and collaborative. I think that's a good idea.
So for homework,
Oh no, okay, yeah.
at least do the odds.
Which
Pages 16 through 19. At least do the odds because we did the evens together. So you've got the odds left. Okay?